Hello everyone! In this video we'll introduce electrochemistry, which is chemistry in which oxidation and reduction reactions take place. But we'll specifically focus on assigning oxidation numbers to elements and compounds. In the images to the right you see pictures of a lithium-ion battery, corrosion or rusting, and electroplating. And these are all great examples of electrochemistry, which is the branch of chemistry that deals with the relationships between electricity and chemical reactions. Oxidation-reduction reactions involve a loss and a gain of electrons. Oxidation specifically is a loss of electrons in which the oxidation state of an element will increase. You can see in this example here we've got aluminum metal with an oxidation state of 0 becoming a positive 3 ion. Its oxidation state has gone up. Whatever is oxidized is called the reducing agent because it allows other chemicals to be reduced. Reduced specifically means a gain of electrons. In this case, the oxidation state will decrease because electrons are negative, and the more we have, the more negative we become. So here's a copper plus 2 ion gaining electrons to become a piece of copper metal or a copper atom. Its oxidation state is going from plus 2 to 0. In this case, this copper plus 2 would be called the oxidizing agent because it will allow other chemicals to be oxidized. Here's a common memory aid that's helpful when you're learning about oxidation-reduction reactions. It's Leo the lion says grr. Leo stands for loss of electrons is oxidation, and the grr is gain of electrons is reduction. What does an oxidation state or number tell us? For an ionic compound, it shows the charge on the ion present in a binary compound. So basically, oxidation state and charge have the same meaning. Calcium chloride is a binary compound because it's made out of two different elements. We know that the charge on the calcium ion is positive 2 and the charge on the chloride ion is negative 1 in that compound. Those are oxidation states. In covalent compounds, oxidation state is based on electronegativity and it describes how electrons are shared between atoms. In CO2, a covalent compound, oxygen is assigned an oxidation state of negative 2 while the carbon is assigned an oxidation state of positive 4. It's not an ion charge, it's just an assigned oxidation state. But this tells us, because the oxygen is more negative, that electrons are pulled more towards the oxygen in this compound. Let's take a look at the rules for determining oxidation states of elements, either by themselves or in a compound. The first rule says all elements in a free state have an oxidation number of 0. So, if we look at these two examples, the aluminum and the bromine atoms both have oxidation states of 0. In number 2, the oxidation number of a monatomic ion is the same as the charge. In copper 2 bromide, the charge on the copper is positive 2 and the charge on the bromide is negative 1. Those are oxidation states. Rule 3 says the sum of oxidation numbers in a compound has to equal the net charge on the molecule or polyatomic ion. This means that the oxidation states of the elements in water have to add to 0, and the oxidation states of phosphorus and oxygen in this PO4 polyatomic ion have to add to negative 3. Here we see that alkali metals, those on the first column of the periodic table, always have an oxidation number of plus 1. As you see in lithium sulfide, the charge on the lithium ion is plus 1, so its oxidation state is plus 1. Alkaline earth metals, that's the second column over, always have an oxidation number of plus 2, as you see here in magnesium chloride. The magnesium has an oxidation state of plus 2. In compounds, hydrogen is positive 1, except in metal hydrides, where it's a negative 1. A metal hydride is when hydrogen is bonded with an alkali or alkaline earth metal. In these two examples, I have the water in purple because it's an example on your paper. You can fill this in there. The hydrogen will have an oxidation state of positive 1, and because we need all of the oxidation states to add to 0, the oxygen must have an oxidation state of negative 2. In the second example, calcium hydride, the hydrogen has an oxidation state of negative 1, and the calcium has an oxidation state of positive 2. In compounds, oxygen is assigned an oxidation state of negative 2, except in a peroxide, where it's assigned an oxidation state of negative 1. Here's some examples. In carbon dioxide and barium oxide, oxygen has an oxidation state of negative 2. In the peroxides, which you see in the next two examples, oxygen has an oxidation state of negative 1. Now, peroxides are compounds where oxygen is covalently bonded to another oxygen in a compound. Probably the most common peroxide you're familiar with is hydrogen peroxide, which has this formula, H2O2. Peroxides aren't common, and often in a question I'll have in a parentheses next to it, hey, this is a peroxide. Next rule, metallic elements in ionic compounds have a positive oxidation number. So in this example, magnesium chloride, magnesium has a positive oxidation state, +2. Next rule, in covalent compounds, the negative oxidation number goes to the more electronegative atom. So we've got two examples here. I have them in purple. They're in your notes down at the bottom. I'm going to go to another clean slide and we'll work on these two. In looking at CO3 - 2, oxygen is assigned an oxidation state of -2, and we calculate the oxidation state of carbon using a little bit of algebra. We'll set up an equation, X plus 3 times the oxidation state of oxygen is equal to the sum of all those oxidation states, or -2. I'm getting that from this number right here. So when we solve for that, X minus 6 is -2. So X must equal +4. That's the oxidation state of carbon, +4. Let's try the sodium phosphate. Sodium, being an alkaline metal, has an oxidation state of +1, oxygen, -2. So we'll set up some algebra. 3 times 1 plus the oxidation state of phosphorus, we'll call that X, plus 4 times -2 has to equal 0 because the sum of the oxidation states in sodium phosphate all add to 0. This boils down to 3 plus X minus 8 equals 0. Therefore, X must equal +5. And that's the oxidation state on the phosphorus. In summary, we looked at the definition of electrochemistry, that branch of chemistry dealing with relationships between electrical and chemical energy. We looked at the difference between oxidation and reduction, oxidation a loss of electrons and reduction a gain of electrons. And we started to look at how to determine oxidation states of elements in compounds.